Hi everyone. Today I wanted to summarise the topic of measurement, just to make sure that you are prepared for the test. So the information that I'm going to go through all needs to go on your notes sheet that you're going to bring into the test on Thursday. You're allowed to bring in one A4 sheet. You can write on both sides of it, but you need to make sure that it is handwritten, okay? So please don't come in with a typed sheet. What we'll do now is we'll start off with the conversion of units, and that can perhaps start with the fact that when we are measuring something in one direction, let me just change colour here. If I go in one direction, that is going to be the length, okay, and you're going to be measuring in millimetres or metres or centimetres, and because you're only going in one direction, those units are to the power of 1, okay? So you need to be making sure that your answer includes units and that they are to the power of 1, which of course you don't in fact have to draw, you can just write millimetres. If you are going to be doing area, you know that you have got two directions that you're looking at. You've got height and width, okay, or you've got length and breadth, and because you are going in two directions, your units are going to be squared, okay? Two directions means that this is a 2. Alright, when you are doing volume, you are going to be going in 3 directions, okay? You've got length, you've got width, and you've got height. Length, width, and height. So you've got 3 directions. So your centimetres or metres or millimetres are all going to be to the power of 3. Okay, and make sure that when you are writing your test that you put your units in and that they have got the correct notation on them. Okay, so when we are going to be converting units, if we are, whoopsie-daisy, here we are, converting from millimetres to centimetres, from centimetres to metres, from metres to kilometres, there are less centimetres than there are millimetres, so we divide by 10. Here we divide by 100, and here we divide by 1000. And going back the other way, we multiply. Okay, so we end up with a larger number of metres than kilometres. We end up with a larger number of centimetres than metres, and we end up with a larger number of millimetres than centimetres. So that is for length. And we're back again to our one direction. Okay, when we are dealing with area, we go millimetres squared, centimetres squared, metres squared, and kilometres squared, which means that when we are going from millimetres squared to centimetres squared, it is divided by 10 squared, okay, or 100, divided by 100 squared, or 10,000, divided by 1,000 squared, and multiplied by multiplied by multiplied by. And then if we go like this, you are able to see, as you would know, if we are going to do volume, we're going to be using cubed. So millimetres cubed, centimetres cubed, metres cubed, and kilometres cubed is going to be the same thing divided by 10 cubed divided by 100 cubed divided by 1000 cubed, and back the other way. Perfect. Very good. Okay, so you also need to understand scientific notation, and this is when a number, usually a very large or very small number, is written as a number that is between 1 and 10 multiplied by 10 to a certain power. So it's either a positive power or a negative power, and probably the best way to explain it is to do some examples. So if I have got 2034900, if I put that in scientific notation, I would write 2.0349, and then what I do is I say that it's multiplied by 10 to the power of, and I work that out by going 1, 2, 3, 4, 5, 6. Okay, so that's the way that we determine that. Okay, if I am going to write a really small number like 0.00493 in scientific notation, I write it as a number between 1 and 10, so 4.93 multiplied by, and here we go backwards, so it's going to be a minus number, 1, 2, 3, 10 to the minus 3. Okay, so this number is between 1 and 10, and here we have got the power that indicates which direction to go to achieve that number there. Okay, so that is scientific notation. Right, then the other thing we need to do is significant figures. Firstly though, I want to show you, and I'm sure that you all know this, if I look at that number 4.93, if I write that to 2 decimal places, I have it as 4.93. If I'm going to write it to 1 decimal place, it becomes 4.9. We round down because the 3 is less than 5. Okay, if I had instead 4.98, I would be rounding up, which means that I would have 5.0 would be to 1 decimal place. Okay, because this goes up, and then that would have an impact on those 2 numerals. When we are doing significant figures, we need to work out what the significant figures actually are. So if we use the example up at the top there, 2 0.03490. These two here are placeholders. However, this, and this are actually the significant figures. So we have, in this case, got 5 significant figures. If we are going to round that to 4 significant figures, we look at the last one. It is larger than 5, so we round it up, and we would have 2035000. Okay, and that would be to 4 significant figures. If we were to round it to 2 significant figures, just taking a jump there, it would be 2000, and then 3 more. So these two are the significant ones, and these ones are the placeholders. Alright, I'll have a look. Oh no, I think I can go like this and have a look at a smaller number. If I've got 0.007324, once again, these two are placeholders. Okay, so we have, in this case, 4 significant figures. If we are going to round it to 2 significant figures, we round these 2 up. Okay, so it is 0.0073. If we are going to look at why we use significant figures, what it does is it actually demonstrates a level of accuracy. We talked about someone who is 16 years old compared to someone who is 16.0 years old. Someone who is 16.0 years old is pretty much, it's their birthday, okay? If they are 16 years old, we use that for a whole year, okay? So this is much more accurate, and although they look as if they're the same number, we know that 16.0 has in fact got 3 significant figures, okay? That 0 is significant. If we are using significant figures, if you are asked to write the area of a rectangle that is 4.2 times by 2.4, what you do is you make sure that your area, and I'm just going to calculate that because my brain isn't working very well. Oh, let me turn that on. 4.2 times 2.4 is 10.08. If we write it in the same way as the question is asked, though, we should write it to the same number of significant figures as the lengths of the sides. Okay, so in this case what we would do is we would choose to write the answer to that as 10.1 metres, say, if they are metres squared, of course. Okay.